Good morning, ma'am, and myself V. Harini, and my roll number is 23401 and my branch is ECA section. And today topic is to determine the Z impedance parameters with the condition symmetric and asymmetric. And I pursuing first BTech in second semester. And subject code is 23888203 and subject name network analysis. And first slide is introduction of the Z parameters. And Z parameters play a crucial role in analyzing electrical circuits. And the condition of symmetry and reciprocity simplify the determination of these parameters. And this presentation will develop into how to determine Z impedance parameters with these conditions. Next one, what is Z impedance parameters? First of all, Z impedance parameters describes the relation between voltage and current in the circuits. And how to find out the Z impedance is the voltage and current between the relation between voltage and current, and to determine the Z impedance parameters. And they are represented by a matrix of four elements: Z11, Z12, and Z21 and Z22. These parameters are essential for analyzing the behavior of linear electrical circuits. And next one, and what is impedance? How to find out the Z impedance? How to find out the uh, admittance means Y impedance. The impedance Z of a circuit in a ratio of phasor voltage to V to the phasor current I, and Z impedance Z is equal to V by I, and or V is equal to ZI. This is formula to find out the impedance. And what is admittance means the admittance YE of a circuit is a reciprocal of the impedance measured in the Siemens, and Y is equal to 1 by V, that is equal to 1 by Z, or I is equal to YV, and to determine the admittance. And impedance and admittance of a passive elements, and element R is in impedance Z is equal to R, and admittance Y is equal to 1 by R, because impedance is a reciprocal of the admittance. To determine the admittance, and it is a reciprocal of the impedance. And in an inductor, and Z is equal to J omega L, and at admittance Y is equal to 1 by J omega L. And also same, the capacitor Z is equal to 1 by J omega C, and admittance Y is equal to J omega C. Next one, since the Z parameters is obtained by open circuiting the input or output ports, they are also called the open circuit impedance parameters. And in the Z parameters is also known as the open circuit impedance parameters. And you know very well, and in this impedance, and the four elements is represented in the Z impedance. The Z11 is a open circuit input impedance, and Z12 is a open circuit transfer impedance from port 1 to port 2. Z21 is equal to open circuit transfer impedance from the port 2 to port 1, and Z22 is a open circuit is a output impedance. And the Z11 and Z22 are also called as input and output drilling point impedance, and Z21 and Z12 are also called as forward and reverse transfer impedance. And condition of symmetry, when Z11 is equal to Z22, the two ports network is said to be symmetrically, and this implies that the network has mirror like symmetry. Symmetry means same, and the voltage to current ratio of one port is equal to the voltage to circuit ratio of second port. Then that particular network satisfies the condition of the network, and the condition of network is Z11 is equal to Z22. And the condition of reciprocity, and when the two port networks is linear and has no different sources, the transfer impedance are equal, and the two port is said to be reciprocal. This means that if the ratio of excitation of one port to the response of another port is same, even though the response and excitation and interchange and the condition of reciprocity, we know write the Z12 is equal to Z21. And next one, this is a diagram. For example, you can find out the Z parameters in this circuit. Entering I1 is entering and positive negative charges in the NA and the network, first one port network and two port second port network. First of all, from network A, and we entering V voltage V1A is equal to V11A I1A plus Z Z12A into I2A. And second, that same network, and we can write the another equation V2A is equal to V21A I1A plus Z22A I2A. These two equations is equation 1. And from network B, V1B is equal to Z11B I1B plus Z12B I2B, and the V2B is equal to Z21B I1B plus Z22B I2B. And next one, from these circuits, the two networks are connected in series. So in series, the current is same. So I1 is equal to I1A is equal to I1B, and also same I2 is equal to I2A is equal to I2B, and the V1 is equal to V1A plus V12. In the connected in series,